Hello YouTube. In this quick video I will be explaining how computers process numbers and how we can write out numbers so that computers can understand them more easily and so that we can understand the numbers that the computers are understanding more easily. So that was kind of a tongue twister, but anyways, here's what I mean. To a human, the number 5 looks like this. To a computer, the number 5 looks like something like that. And basically, the numbers that the computers understand are basically called bytes, or binary numbers. A byte is basically 8 bits. Here, hold on one sec, I'll change these all to zeros. But anyways, a bit is what these are. It's either 1 or 0. And byte, again, is made up of 8 bits. So we will be dealing with 8-bit numbers, and I'll be explaining how you can turn a string of values of 1s and 0s into a number that a human can understand and vice versa. So how do we basically convert a number that humans can understand into a number that computers can understand? Well, I'm going to teach you guys how to do that today. So let's start out with a simple number, 5. So how do we discover what the value of 5 equals in basically binary numbers? Well, here's what you do. See how I have basically the value n, which is the index of the number, meaning that this is the 0th number, this is the 1st number, and so on through the 7th number. Technically this is the 8th number, but we started at 0. So yeah, and that makes it more easy for our formula, which is the function is 2 to the power of n. And here's what I mean. Basically 2 to the 0th power has a value of 1, because anything to the 0th power is 1. 2 to the 1st is 2. 2 squared is 4. 2 cubed is 8, and so on until we get to 2 to the 7th is 128. And by the way, guys, you can deal with numbers past 8 bits. Like you can deal with, 64-bit numbers and 128-bit numbers and stuff like that. But for the sake of this video, I'm just going to be dealing with 8-bit numbers. So yeah, that is how the index value, the n value, corresponds with the numerical value. Now, how we convert a number like 5 into binary numbers is this. So again, we're dealing with 5. Does 5 go into 128? No. Therefore, this bit stays at 0. Does 64? Still no. 32? No. 16? No. 8? No. 4? Yes. So since 4 goes into 5, we simply change this number to a 1, and we subtract 4 from 5. So now the number we are dealing with is 1. Okay? So now, does 2 go into 1? No, 2 does not go into 1. Does 1 go into 1? Yes. Therefore, we change this number to a 1, and 1 minus 1 is 0, and therefore we are finished. So how do we test to make sure our output is what we expected? Well, I'm using C++ right now, and I'm going to write a quick little program that can demonstrate that 5 is equal to this. So, basically, what I'm doing is I'm printing out an 8-bit number of the number 5. There we go. If you guys don't know C++, don't worry. You won't have to really have an understanding of C++ to demonstrate what I'm trying to say. So let's debug this, and here we are. Now, if we were right, which we are, 5 equals 0, 0, 0, 0, 0, 1, 0, 1. And that can be demonstrated by looking at this, 0, 0, 0, 0, 0, 1, 0, 1. So we were correct. 5 in binary numbers does in fact equal this. So that is how we basically convert a number that humans can understand to a number that the computer can understand. And if you want, you can keep on doing the same kind of thing with higher numbers and stuff like that. But I'm going to move on to how we can convert basically a number that the computer understands to a number that we can understand. And I'm going to show you guys a pretty good strategy for figuring this out. You know how when we were basically inventing a number that computers can understand, we started from left and worked to right? Well, when you don't really know how many values are in a byte or are in how many in the number of bits that we're working with. Whoa, what just happened? Okay guys, I'm gonna pause the recorder real quick to see what happened, and then I'll be right back. Okay guys, it was just a little glitch. I guess I'll get right back on it. So what I was trying to say is basically, if you know that the numbers that we're working with has exactly 8 bits, then what we can basically know that we can start at the number 128 and work our way down. But when the computer gives us a number, like a 64-bit number or something, we're not going to want to calculate all the way up to 64 and then work our way down when we're simply trying to convert that number into a number that we can understand. So it's best to start from right and work our way left. So let's say we had whatever this number is, I don't really know, but we're going to figure that out. So we start basically over here, because guys, you're not going to have this chart to work with all the time when you're calculating numbers like this. So you can start out, okay, so 0th index has a value of 1 again, and then we can know that second one has 2, third one is 4, and there's 1 right there. So we add 4 to our equation. Then we add 8 to the equation, because again there's a number 1. So now we're at 12. Then we have 16. So 12 plus 16 is 28. So therefore, this value right here is 28. So that's way easier than trying to invent our own binary numbers. And you saw how it was kind of a hassle to make basically binaries from binary numbers from regular numbers that humans can understand. And really, like seriously, if we wanted to actually make numbers, like actual binary numbers, we're not going to say our phone number is like da 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 da, and like do this huge string of binary numbers and stuff. So is there really a way to display binary numbers more efficiently? Because humans can understand more than just ones and zeros, unlike computers. Well, guess what? There is a way. And that is hex numbers. So hex numbers are basically a more efficient way of displaying binary numbers. So yeah, I'm going to take a quick break, guys, and when I come back, I'll be explaining hex numbers. So I'll see you guys then. Okay guys, my break's over, and basically what I'm going to be explaining now is how we can work with hex numbers. So, you know how in binary numbers, the only numbers that we could work with were either zeros or ones, which is basically only a base 2 system? Well, that is really inefficient for humans, and humans can work with numbers way higher than just ones and zeros. So, you know how our formula for binary numbers for calculating the value was 2 to the power of n? Well, guess what? For hex numbers, it's 16 to the power of n. So this basically means we're working with the base 16 system with hex numbers. So, okay, you might be wondering, if we would normally work with the base 10 system, I think this is going a little bit too high. Working with the base 16 system, we don't have numbers, single-digit numbers, that go up to 16. Well, yeah, we kind of do, but we kind of have to cheat to do it. And here's what I mean. I'm just going to create a quick variable here, and I'm going to basically, where was I going with this? Basically, I'm going a little bit ahead, but here's what we do. For numbers 0 through 9, which is our base 10 system, we just use numbers 0 through 9. But if we want to deal with numbers 10 through 15, which is as high as we can go with our hex numbers, then what we need to do is use letters A through F, A being 10 and F being 15, and the other letters fit in respectively. So basically, let's just create a simple number for you guys so that you can understand what I'm doing here. So now I can create a number, and I'm just going to say 0xb. And guys, this might look totally foreign to you because you don't know what the 0x is yet, but basically, whenever you want to tell the computer that you're working with hex numbers, you basically just have to say, okay computer, we're going to be working with the hex numbers, so we're going to write 0x right here. Because if we took that out, look, b, the computer's like, okay, what in the world is b? B is not defined yet. So if we say 0xb though, the computer's like, oh, okay, you're working with a hexadecimal number, because otherwise it would be confused that we're working with letters. So anyways, again, whenever you're working with hexadecimal numbers, you have to put the 0x in front, otherwise you're going to get a bunch of errors. So 0xb, can you guys guess what that is? While I'm typing this out, you can probably try to figure it out. And basically, B, remember, so if A was 10, then B is 11. So if we debug this program, then we will find that B is equivalent to 11. And there we go. We are correct. So now that we figured that out, let's go a little bit more advanced. Let's do the number, I don't know, 28, perhaps. So let's work with 28. So basically, how do we figure out the number 28? Well, again, remember how we were working from left to right and just kind of calculating our numbers when we were trying to figure out binary? Well, we're going to be working from left to right also with hex. So let's start, 16 to the 7th power. That's a really high number. So again, 28 definitely does not go into 16 to the 7th power. And guys, the reason I just wrote out 16 to the 7th here is because 16 to the 7th, in case you guys know anything about math, is an insanely high number. Like, with 8 digits with hex, 16 to the 7th power is huge, whereas in binary, we can only work up to 128. Like, really binary, is that the best you can do? Unfortunately, yeah. So that's why we use hex. Anyways, of course, 16 is the largest number that we can get into 28 without exceeding it. So now that we know that 16 can go into 28, how many times can 16 go into 28? Well, just once. And 28 minus 16, guys, remember how we're doing with this with binary? 28 minus 16 is 12. So how many times does 1 go into 12? Well, 12 times. But we can't just simply write 12 here because, again, the computer's going to get a little confused because we're dealing with 2-digit numbers instead of 1. So to write out 12, we need the letter C, remember? Because the C has a value of 12. So let's see if we were correct with our calculations. So apparently 0x1c is equivalent to 12. So let's debug our application real quick. And if we get the number 28, there we go. We are correct. So let's do a little bit of a higher number. Let's work with the number 52. Sounds like a pretty good number to me. So again, 16 is the highest number that can go in 52 without exceeding it. So what we need to figure out is how many times does 16 go into 52? 3 times. And 16 times 3 is 48. So 52 minus 48 is 4. So therefore 4 is what we're left with. So how many times does 1 go into 4? 4 times. So we're going to put a little 4 right there. So apparently the number 52 in hex is 0x34. Now, this does not mean 34, it means 52. And we'll find that out when we run our application. And we get the number 52. Sweet. That is awesome. So, yeah, we can do some pretty good numbers, but once we're dealing with, I don't know, high numbers like, 16 to the 7th power, for example, we're not going to want to calculate ourselves the hex value if we want to do binary operations. So is there an easier way to really calculate the value? Unfortunately, no. But guess what? We can make a way to do it. And this is the advantage of being a programmer, guys, is you know how to do this kind of thing. And again, this is pretty basic programming, so if you wanted to learn this, it wouldn't take very long, or you could just watch the rest of this video. So what we're going to do is we're going to create a simple integer. Let's not use I, let's use input. And we're just going to set the initialization value to 0. And we're going to print out on the screen, enter an integer here. Okay, that's pretty cool. So, and then we're going to use the input to basically set it to the input value that we created up here. Remember? See how those are both highlighted? That means that this is the same variable. So basically, we're going to output, enter an integer here, and then the user is going to input and set the value to our integer. So, and then we're going to basically do cout the hex form is 0x, and then what we can basically do is, guys, I've imported the IO manipulate class here so that we can do std hex value of the input, and then put a little end line here. So, oops. So there we go. What it's basically going to do is say the hex form is, and then it's going to say the hex value of the input, and then it's going to go to the next line so that we can input our value again. So I'm just going to do a little go to thing here. Go to start. And basically, guys, in general, you don't want to use go to because they can make the code really hard to follow. But since the program is so small, it won't be that much of a deal. So let's debug our application, and to confirm what we are doing, let's just do a simple number because we remember what we were working with. So again, 3, 4, and that was, what number was that? That was like 52 or something, 52, and the hex form is 0x34. So we have confirmed that this hex calculator is working. So wow, this is a piece of cake. All we have to do is type in the integer value and it returns the hex value. Yep. So let's do a little bit bigger number. Wow, still works. Still works. So this is really useful in case we're wanting to do any bitwise operations. So if you guys want, you can go ahead and export this project to an executable file and put this on your desktop, so whenever you're doing some programming stuff and you want to get an accurate hex value, then you can just plug it into that program that we just wrote and you'll be all good, so that you don't have to calculate all this yourself. So yay for us, and I hope you guys enjoyed. I hope you guys have a good understanding about how computers read numbers and how we can make those numbers easier to read ourselves. So yeah, hope you guys enjoyed, and I'll see you next time if there is a next time.